Okay, let's look at the homework 5.1, 5.2, problem number 12. Alright, so we want to express this definite integral as the limit of Riemann sums, and it says that we use the right endpoint, so we use the basically right sum. Alright, so let's do that. Alright, so we know that this is going to be limit. Right, so we're getting greedy, so we send the number of rectangle to infinity, right? Then the summation, so you have n rectangles, and usually starts from I equals 1 to n. Alright, then remember that this is going to be f of xi, right? And times delta x. Alright, and we know how to find delta x, right? So delta x is simply, right, find the length of the interval, which is just upper limit minus the lower limit divided by n, right? So in this case, upper limit, so b is 9 and a is 1. All right, so what we have, so this is going to be 9 minus 1 over n. So this is just simply 8 over n. All right, then let's see, we want to find xi. So xi is simply a plus delta x I, but we already know what a is. A is 1, so it's going to be 1 plus, right, delta x is 8 over n times I. Alright, so that's xi. Right, so function is f of x is just the integrand. So in this case, x minus 3 natural log of x, right? So seems like we know everything we need to know. So this is going to be a limit, right, as n approaches infinity. Summation I goes from 1 to infinity, right? F of xi, so this is f of x, xi is this guy, so we just have to plug it in. So we're gonna get 1 plus, I'm gonna write it as 8i over n, right, minus 3 times natural log of 1 plus 8i over n, then multiply by, alright, delta x. Delta x is 8 over n. Alright, so let's type it in. Alright, so answer was, parenthesis, alright, another parenthesis, 1 plus 8i over n, right, and parenthesis 3 natural log of 1 plus 8i over n, parenthesis, oops, that's not where I want it, parenthesis, right, and times 8 over n. All right, let's see, 8. Oh, right. Oh, okay, we have that. All right, so that's that. Let's check the answer. Okay, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.